Hi guys, we're going to be looking at today a TEKS by the name of 7.12b, which is where we would be using a random sample to make an inference of a population. We're going to be looking at the purposes of this video for questions number 6 and number 7 there on the screen. Now, we are going to attempt, if we know the ratio of a random sample, how can we predict what that might be in the larger population? Okay. If we look here at this particular problem, it says that a manufacturer fills an order for 4,200 smartphones. The quality inspector selects a random sample of 60 phones and finds that 4 are defective. How many smartphones in the order are likely to be defective? So what we need to do is we need to figure out of that ratio that's given to us for that random sample, how does that actually expand itself to the overall population? How many could we expect to be bad? Many manufacturers will use data like this, so there is definitely a real-world application for this. So the first thing that I want to do is I want to go ahead and go over to my work. Okay, so I see that, first of all, I want to go ahead and set up a ratio. Okay, so I know that 4 out of 60 are going to be bad. Okay, so I know that there are 4 bad phones. This is the total sample. Okay, now how could I make that equal to my overall population? If I know that a certain portion of those phones, of those 4,200 phones, are still going to be bad, if I expect that in this random sample that there will be 4 out of 60, how can I make that a certain number into my total population? So what I want to do is I want to set up a proportion. I could even set up a proportion box. Okay, so I know that this is an imaginary equal sign if I set up that box. Okay, I know that this is a part of the whole of the sample, so I want to know what part of my total population that will equal to. Okay, so at this point, I can do one of two things since I have this proportion. I can say, okay, what number would I use and what operation would I use to get from here to here? If you can't see that, then there just may be an opportunity for you to use cross multiplication, which I'm going to do. Cross multiplication tells me that I would multiply 60 times x, and that's going to equal 4,200 times 4. Okay, for the sake of time, what I'm going to do is I'm going to let you know that that is 16,800 when I multiply that. So now this just becomes a regular one-step equation. That regular one-step equation, since I know that this is multiplication, in order to isolate my variable, I'm going to do the opposite operation, which is division. This becomes 16,800 divided by 60 through the power in the magic of YouTube. When I divide these two out, that's going to give me 280. Okay, so I can expect out of the 4,200 that approximately 280 of those phones would be bad. So my solution statement tells me that approximately 280 of 4,200 phones are expected to be defective. Okay, so if you need to go back and look at that again, certainly you may do so. All that I did here was take 16,800, divide that by 60. Okay, now if you want a shortcut, you can actually cross-simplify some of those zeros, and it makes it a little bit easier for you to divide. Okay, but the check is that I could multiply 280 times 60, that'll give me 16,800. Okay, whichever you'd like to do. But that is what's expected of that greater population. Now, let's go back, and I want to look at the previous problem. So, question number 7 tells me that part of the population of 4,500 elk at a wildlife preserve is infected with a parasite, like some sort of tick or something. A random sample of 50 elk out of that overall population tells me that 8 of them are infected with that parasite. Now, how many elk are likely to be infected? I'm going to use something very similar to what I just did for the previous cell phone example. So if we go back to my work, I see that I expect that 8 out of 50 randomly selected elk are infected, and I'm just going to say, because I like deer, they're infected by a tick of some sort, okay? The total population, I'm going to write this down for myself. Total population is 4,000, oh, no, sorry. Just thinking money, sorry. 4,500 elk. Okay, so I'm going to use something very similar to what I did earlier, okay, where I'm going to set up a proportion. That is 8 of 50. So with ticks, total sample, I'm going to set that equal to the total population. So remember, part over whole, some part over the whole population are expected, okay? So again, I can either multiply 50 times some number that'll give me 4,500, but if that's not popping out of my brain, what I would do is just do cross multiplication. That's 50x. And again, through the power of YouTube, that is going to be 36,000. So now, again, it's just a regular one-step equation. I'm going to isolate my x value by dividing each side by 50. I'm going to cross simplify my zeros. X is going to equal some number, which I will fill in. But what I'm doing down here is I am dividing 3,600 divided by 5. Okay, when I divide that by 5, becomes that. Okay, multiplying that by 2 gives me 10. I'm now down to 0. The only thing left is 0, so I'll put 0 up here. So that becomes 720. My solution statement is that 720 elk are expected to have the parasite out of 4,500. Okay, so what I want you to do is I want you to back this video up if you need additional questions answered. If this is not making sense to you, please ask me in class about how it would actually solve. And you are also welcome to tutorials on either Tuesday or Thursday. And by all means, I look forward to seeing you tomorrow in class.